Okay, yeah, output transform divided by the input transform. Okay, so let's say we have this example. Ano siya? O, klaro kayo, parallel lang siya, di ba? Posible di mo kailag parallel. So R of S, by the way, we call this system still as a SISO system. SISO. Ano naman? Ano meaning sa SISO? SISO system. Anyone? Ano meaning sa SISO? Manawag ko. Kaya may matubag. Sige. Ayan to. What do you mean by a SISO system? Hmm? Ito yung meaning anang SISO nga system.
Kanang single input and single output, sir?
Yes. So a SISO system is that's the abbreviation for single input, single output. Okay. We also have what we call a ayun. We also have what we call a MIMO system. Obviously, that's multiple input, multiple output. Okay. But for this course, we'll be focusing on SISO systems only. Okay. Sometimes we will have multiple inputs, but we can aggregate the multiple inputs into one output or one input. No, maybe that's through a summer or a summing junction, or we aggregate them by any transformation na method. Okay, so this is an example of a parallel system. So notice that R of S is distributed through a pick-off point to G1, G2, and G3. No, G1, G2, and G3 are all plant transfer functions, and they are connected in parallel. So meaning the output at G1 of S is simply R of S times G1 of S. Ano, no? Similarly, for G2 of S, the output at that transfer function or that plant is R of S times G2 of S. No? And so on. Okay, so regardless of the sign, whether that's plus minus, no, sa imong summer, you just take the algebraic sum. So klaro kayo, di ba? Our C of S is just plus minus G1 of S plus minus G2 of S plus minus G3 of S. No? You enclose that in a bracket or a parenthesis times the input. Okay? Therefore, that transfer function sa imuhang parallel nga system, kana siya nga example, no? Ang imuhang transfer function is equal to the algebraic sum of your GIs, GI of S. No? To N. No? Very simple, algebraic sum. Okay? But of course, no, taking the sign of your transfer function. Or taking the sign, the output or the signal coming to the summing junction. So kung negative, negative sa na diha. No? Negative GI of S or G1 of S, ano na, no? And so on. Okay? Let's see. So the equivalent na transfer function is kini. So plus minus na siya, no? Kay arbitrary man, wala takabaw unsay ang kuan ang ato ang summing junction nga signs. Na siya. So this is the open loop na to nga system or block diagram. Okay? So parallel systems multiply. Cascaded systems, sorry, parallel systems you add. Cascaded systems, you multiply. Okay? But there are times no nga imong system is a combination of a cascaded and parallel system. Of course, very similar with your circuits classes, we have series parallel or parallel series ng mga circuits. Okay? And lastly, the third one is what we call a feedback system. Okay? So in this course, we will be focusing on feedback ng mga systems. So there are a lot of advantages for a feedback system, but also a lot of disadvantages as well. No? So let's tackle first our advantages sa to ang feedback ng mga system. So the first one is that many unnecessary disturbances and noise signals from outside the system can be rejected. So let's say for example, no, we have a very simple na kanang feedback system. Let's say this G of S, see ya. This is C of S here. This one is R of S. No, this is what we call a unity feedback system. Because, nga naman, ganong gitawag man siya nga unity feedback system. I will call si apat. John Paul apat. Ganong unity feedback system man siya. Because H of S is what?
Okay, di sir.
Okay. So, the reason why it's called a unity feedback system because your feedback na block no is actually a gain block which is equal to 1. Okay? So, dili na siya basta 1 gani imong gain, dili na siya nimo ibutang or i-represent as a block. No? 'Di ba similar as writing like a polynomial, let's say x squared plus 3x plus 2. Ana. 'Di ba dili na ka magbutang 1 diha? No, sa imong x squared. So, more similar na siya nga idea no sa imuhang um feedback no nga block. Okay? Pero if it's less than or greater than 1, you have to indicate no unsa siya nga gain nga value. Okay? So for transfer functions or transfer function or representation sa isa ka subsystem, rectangle tong gamiton. If gain gani no, gain gani, that's a constant. Okay? So for all gains, ang representation is a triangle, no? Murag pizza. Or there are also times nga your gain is also a transfer function. Okay? Which is pwede ra na siya gihapon. Okay? Regardless, usually ang mga gains gyud na representation is kini rectangle. Okay? Okay. So, going back to the topic, so let's say for example, this is our simple na unity feedback system. Okay? So, for a feedback system, your output is compared to the input. Sometimes the summer, no? Sometimes the summing junction is also called a summer. No? Tigsum. Or there are usual na cases nga it's called a comparator. But kining comparator nga term is usually used in implementation in electronics, no? Para mag-implement na ka sa imong system. Regardless, they both bear the same thing or same meaning. Okay. So kini siya, this is a unity feedback system. Specifically unity negative feedback system, because the feedback signal, no, is coming to the negative nga junction. If it's positive, that's a unity positive feedback system. Okay? So ana ra na siya ang kanang naming nga convention. So kaning ingon nga many unnecessary disturbance and noise signals from outside the system can be rejected. So ang pasabot ana is that kaning reason. Let's say for example, we have a disturbance, no? So when we introduce a disturbance or noise, we pass it through a summer. Okay? So mag-add ta og disturbance. Let's say that's DU. Sa atong feedback, mag-introduce ta og noise. Ana siya. No? Let's call that N. So kini silang mong disturbance, no? Kung imo na siya or if ma-include na siya sa input padong sa mong plant transfer function, so there's some output response, let's say C of S. That C of S is fed back again, fed back again to the system. But if your feedback system is introduced with a noise, ma-appeal na siyang noise, no? Until it goes to the summer, no? Or sa summing junction. Now at the summer, it will compare, no, the signal, no, the output signal or the feedback signal with R of S. Okay, so there is some form of comparison between the signals, no? And we can reject, no, both disturbance and noise through a controller. Okay, kini wala pa ni siya controller. Okay, vanilla ni siya nga unity negative feedback system. Okay, the second one is the change in the performance of the system due to parameter variation is reduced. Okay, especially if you have a controller, no, you're more likely to reach your target na set point, no, which is your input. Okay, and the steady state error of the system can be relatively small because there is one way for you to compare the error. Okay, so ang error asam na siya dapita. Let's delete the noise and disturbance. No, so ang error diri na nga signal. Okay, kana siya E of S. Okay, so basically E of S is equal to R of S minus C of S times H of S. Okay, no, if the H of S or your feedback block is just a gain 1 block, then that's just R of S minus C of S. Okay, so this error signal, no, this is your actuating na signal, and the ratio C of S to E of S equals G of S, no, or kung naapabangan na isumpay diha basta kay C of S over E of S, this is what we call the open loop transfer function. Okay, so if ang path kay padidto ra, that's the open loop transfer function. If we take the total transfer function of the system, no, by taking the feedback loop, we call that the closed loop transfer function. Okay, and we will discuss that later on. Okay. Number 4, no, the transient behavior of the process can be easily manipulated, and of course that's through your controller. Okay, So your controller needs an actuating signal or an error signal. Nga naman, you cannot implement a controller with an open loop na system because there is no error signal nga ma-measure. No, let's say you have an open loop system. No, C of S na imong controller. G of S ang imong plant. Yung imong output, let's say that's Y of S. Yeah, input R of S. Why gamit imong controller? Mahugra makaskade ra na nimo. No? So ang mahitabo ana imuhang transfer function depende sa klase sa controller. Kung imong transfer function kay let's say a type N na siya, no? Either type 0, type 1 or type 2 nga transfer function or plant nya imuhang C of S, let's say maybe like 1 pole 1 0. So if you cascade that, di ba mahog nga C of S times G of S. And that actually makes your system much complex. Diba? Because you're introducing another pole and another zero to the system. So there are times, no, especially when the controller is not defined properly, then your system will become unstable. Okay? Pero this is not observable, no, in practice. Kay wala gamit yung controller kung wala kay error signal, no. R of S is not an error signal. Okay? You need a comparator or a summer to measure the error signal. Okay? So let's delete that. Okay? Naman, no? The feedback is compared with the desired state in order to take corrective measures. Ano siya, no? Ang ato ang feedback loop. The use of our feedback loop. So these are our advantages. How about mga disadvantage? The first, no, concern for a feedback system is that it makes the total system complex. No? Nga naman, because you're introducing a feedback loop. So meaning you have to have a mechanism, especially in the implementation, dapat na kay mechanism to collect the output response na imong i-feed to the comparator. Okay? And you do that through sensors and error detectors. Okay? So kanang sensors mahug na siya nga mao na imong feedback na system, no? Because you have to sense the output. Your error detector is your summer kana, no? There are a lot of comparator na mga circuits, no, or implementations. Okay? Next. The overall gain of the system is reduced and must be compensated for in the design. Of course, no kay mahog man nga when you take the closed loop transfer function, there are times na ang imuhang gain mugamay tungod sa algebra or tungod sa algebraic manipulation of the system. Okay, so you have to compensate that, no? You have to include I don't know, maybe like a proportional, no, nga controller, or you have to increase the intensity or number of the gain sa imong proportional controller for a while. Okay. No? Sumato siya. Third one. The system may not be stable. It may oscillate or depart greatly from the desired output. And this is usually caused when you have a controller nga sayop pagka-design, no? Sometimes a controller is also called a compensator. That's why ano siya, must be compensated. So a compensator, it's more of like a general term, no? So if sayop pagka-design ang compensator or controller, mo unstable yun yung system, no? Especially when you introduce the wrong zero or the wrong pole na. Yeah, kana number 4, the error detector is necessary to in order to compare two states. Nya imong error detector di man na abstract nga kanang kuan, di na siya abstract nga component, no? You have to find a physical implementation of the error detector. Okay? And lastly, if there's a change in output, it will affect the system input, no? Kay kung naani disturbance after sa imuhang output signal, say diha ano naa kay disturbance. Let's say another disturbance, DU or DC. Okay? So mausab mo kuan C of S, no? And it will affect the system input as well. Okay? Hmm. So mao na siya no tong advantage sa feedback ng mga systems. Okay? For a while lang ha. Okay, I'm back. Sorry for the interruption. Okay. So, let us go to feedback systems. So the common no na representation of a feedback system includes this mga kini nga mga kuan nga mga blocks, no? So we have an input transducer. Sometimes this is not an input transducer or this is not a transducer. Usahay kay pre-filter siya nga block, no? So maybe you want to filter I don't know, like a frequency or some magnitude sa imong input, then you need a filter. Or let's say you want your input to be a signal nga mabasa sa imong system. So of course you have to use a transducer. No, kay what if imong signal, imong original nga signal kay mechanical, pero imong system mo take og electrical nga inputs. So you need to transduce that signal. Okay? Another one is the controller, no? Naka-importante, no, for feedback control. Next is your plant, no, of course, your system, your original na system na you want to control or improve. Tapos we have two kinds of feedback nga block. What if you want your output to be transduced into another form of signal? Then you need to have an output transducer. But most of the times, this is not used, no? Okay? Kay, kini diri nga loop, i-assume naman ni nga this is the same signal, no? Or the attribute of the signal is the same all throughout. Let's say electrical na siya nga signal or mechanical nga signal. So maybe that's most of the time wala ni siya. No? On special cases ni siya. And of course the feedback na block, no? Sometimes this is called the sensor. So in your maglev model, that's the sensor na block. Okay? Mo siya no ato ang feedback, no? Usual nga naman sa itong feedback na system. But if we cascade this one and this one, we can have a plant and controller na transfer function. Sometimes it's called G of S, no? Feedback, no? Kana silang duha, i-cascade, ara tayo H of S. Okay, so this is the usual, no, na architecture kung G of S o H of S ra ang atong i-leave na mga blocks. Okay? And how do we get the total transfer function, no? What is C of S over R of S? Okay. So let's prove that, no? Nganong inana siya? No? How did we come up with kining figure C? Okay. So looking at your transfer function, di ba we know that E of S, no, is the input coming to G of S. Okay, and the output is C of S. So meaning C of S di is equal to E of S times G of S. Or E of S is equal to C of S over G of S. Okay? Now, at the summer or at the summing junction, di ba, that the output signal E of S, output sa ato ang summer kanang E of S, di ba that's equal to R of S or minus plus unsa man na siya, di ba kini yung signal, no? And that signal is the output or the output of the signal nga C of S times H of S. So this is C of S times H of S. Okay? So if we superimpose both E of S, this becomes C of S over G of S is equal to R of S minus plus C of S times H of S. Okay? And how do we get C of S over R of S? No? Saan man na siya? How do you think we can do that, man? Pwede ta mag C of S over G of S. Kini siya, kini nga part, balhin dito. So, ang kanang plus minus, or minus plus, may mo na siya, plus minus. C of S times H of S equals R of S. No? So, you can see the pattern. Pwede na to ma-extract ang C of S. So, that's C of S times 1 over G of S plus minus H of S equals R of S. No? Therefore, C of S over R of S is equal to 1 over G of S plus minus H of S the power of negative 1. Okay? And sa man na siya. So ato ning i-simplify ha. This becomes unsa man? That's 1 plus minus G of S times H of S, no? All over G of S raised to the power of negative 1. Klaron kayo, no? C of S therefore, C of S over R of S is equal to G of S over 1 plus minus G of S times H of S. So ano siya? That's the same thing. So if we have a negative na feedback system, no? Kining imuhang sign plus na siya. If we have a positive na feedback system, imuhang sign diha is negative. So baliktad. Okay? So I hope no nasabtan ra ang kuan. Kini ato ang solution. That's basically just algebraic manipulation. Okay? So kini very important to nga equation that you will be using all throughout when analyzing mga feedback systems. Okay? So as much as possible, you make sure that the system or the block diagram can be represented as a very simple nga feedback na system. Okay? Okay, so let's continue. So there are also other times na you have systems wherein you have to move blocks, no? Kaya nga naman, para ma-synthesize nimo ang block diagram. Okay? Because there are times na a block diagram cannot be simply synthesized if you just leave the original system as it is. So meaning you have to do a little manipulation for your current na block diagram. So ingon diri kini siya nga block diagram is similarly equal to this one. Siya, di ba? So unsa man na? Let's check if they're true, no? So at the summing junction we have R of S minus plus X of S. No? So mao na diri ang output kana diha dapita. Kini siya R of S minus plus X of S. No, which is the input to the transfer function. So to get C of S, we multiply this by the transfer function. That's equal to C of S. Okay? So mao na atong equation sa atong output. How about the block diagram at the right side? Is that the same? So let's check, no? So unsa man ang output diri after sa G of S? Diba that's just R of S times G of S. And how about the output at here? Diba that's minus plus X of S times G of S. No? So atong gisum ang duha ka outputs kana o kana. So therefore, the total output is C of S. So, diba that's just the same thing. Sige, para maklaro. Atong i-factor out. No? We can factor out G of S. So, diba they're the same? No? Meaning, this system is the same as, or this subsystem is same as this subsystem. Okay? Sige, how about this one? Wala siya. Sige, so let's check if that's the same. No? So the output here is R of S times G of S. And the output, or the, yeah, the input to the summer is x of s, no? Minus plus. So minus plus x of s equals the total output c of s. Is that the same as this one? So let's check, no? So coming to the summing junction, that's r of s, positive r of s, and sa man yun, sa man ang output dire. Diba? That's just x of s times 1 over g of s. So meaning that's minus plus x of s over g of s. Equals. Kana siya dapita. Kana siya diha. So unsa man ang output diha? Ang atong output atong gi-multiply or atong output mo atong gihimong input sa g of s. So di pa ni siya equals. Siya ma-erase. There. So kana siya nga output, kini diri nga output gihimong input for g of s. So para makuha ang total output, that input times g of s equals c of s. And obviously, that's the same thing, no? If we distribute, that's r of s times g of s. And this one cancels out. Minus plus x of s equals c of s. So, di ba? Pareho na siya. Tanan. Okay. Okay. Let's have another example. Ana siya. Okay, obviously, hindi na ako mag-write, no? Easy rin man eh. Obviously, our r of s is or has a peak of point, no? So meaning r of s is distributed 3 times, no? So r of s is taken as an input to the transfer function g of s. So meaning ato ang output klaro kayo r of s times g of s. Kini wa may transfer function dara, the gain is just 1. So r of s remains r of s. So the output is just r of s gyapon. And also for this one. Now, is this the same? Is the right diagram the same as the left? Okay. So arita. So our pick of point is at this part, no? Or kani siya nga node. So the output to r of s or the output to g of s if given an input of r of s, mahawag na siya nga ato ang kuan signal diri is equal to r of s times g of s, no? Sent off to a pick of point mana siya kana r of s times g of s, which is just the same para kina o kana. Okay, sunod, no? Di ba ato ang pick of point yang gisend nga signal kay r of s times g of s, we send that to a block with 1 over g of s, makancel imong g of s. So it remains r of s. Ana, output niya r of s ra gyapon, which is the same here. Okay? And also the same thing here. Mao na siya. Okay? So this this diagram is the same as this diagram. Okay? Lastly, kini siya. Of course, obviously, if you apply r of s to g of s, your output is just r of s times g of s. At the pick of points, wala na may laing blocks. So, ano siya, ang output is sent thrice, no? Through the pick of point. Which is just the same also as this one, no? If r of s is your input and the pick of point sends it to 3 na path, so this becomes r of s times g of s. Kana. R of s times g of s, kana, and so on. Which is just the same. Okay. Tama na siya. Questions? Questions?
Wala ra, sir.
So easy ram na siya. Okay. So now I will be going to MATLAB. I will show you how the control system designer works, no? Because you will be using this for your project. Okay. So if you go to MATLAB, you go to the apps tab. Ini, nasa top, no? Apps, and then you click this drop down button, you find kining control system design and analysis. Siya. Okay? And you look for the control system designer. That's usually the first one. Siya. Nakabutan dere design CISO controllers. Because actually si control system designer, controller ay mo i-design diha. Mainly. Okay? Okay. So let's say for example, balik ta dere. Uy, di ma-zoom. Later na siya. Uy, na. Let's say we have a feedback system. It looks like, let's say, negative na feedback system. Now we have, let's say, a controller and a plant transfer function, which is G of S, and the output, let's call that Y of S, no? Kini R of S. Yeah, na tay feedback na block. Yeah, negative feedback ta. Oh, negative feedback. Okay. So, unsa to'y closed loop transfer function na to? Diba? That's equal to Y of S over R of S, which is G of S, no? Let's not use G of S. Let's use GE of S, no? Kaya kini wala pa man ni siya na synthesize into one. Let's just call that GE of S. All over 1 plus minus GE of S times H of S. Okay. Sige. So let's say our controller is just 1. 1 na siya, meaning it's a gain block. Proportional na siya. How about for our plant? Let's say the plant transfer function is 2 over S plus 2. And our feedback na block is 1 over S plus 1. Ana siya. Sige. Solve for the closed loop transfer function. I'll give you 5 minutes to do that. Go. Okay, so let's continue. So someone put an answer on the chat box, pero dili siya simplified. Okay? Remember when you're doing analysis of your feedback or your control system diagram, your transfer function must be a ratio of polynomials, no? Dili rational functions or rational nga mga expressions. Okay? So let's try to answer this one. No? So we have to first get the equivalent plant and controller transfer function, which is simply just 2 over s plus 2, di ba? Okay, that's just 1 times 2 over s plus 2. So let's write that 2 over s plus 2. And then because this is a negative feedback system, that's 1 plus ge of s times h of s, which is 2 over s plus 2 times 1 over s plus 1. So this is equal to, saman. So that's 2 over s plus 2, then 1 plus 2 over s squared plus 3s plus 2. Diba? And if we simplify this further, that's 2 over s plus 2 times all over s squared plus 3s plus 2 plus 2 over s squared plus 3s plus 2. Diba? So this is now 2 over s plus 2 all over s squared plus 3s plus 4 over s squared plus 3s plus 2. Okay? And by division of rational expressions, that's 2 over s plus 2 times s squared plus 3s plus 2 all over s squared plus 3s plus 4. No? But we know that the numerator here can be simplified as s plus, or can be extracted as s plus 1 times s plus 2. Diba? And we have similar terms or similar binomials. We can cancel them out. So meaning your closed loop transfer function is 2s squared plus 3, sorry, not 3, plus 6. No, balik, sayop. So that's 2s plus 2 all over s squared plus 3s plus 4. So mo ni mong closed loop transfer function y of s over r of s. Okay? So very easy. Now we also have what we call the forward I forgot the term, no? The forward path transfer function. So the forward path transfer function is just your errors diba error signal na diha. So your forward path transfer function is just y of s over e of s, which is simply just c of s times g of s. Diba? Ano siya. We also have what we call the open loop transfer function. That is the saan ni siya ha? That is the product of your GE of S times H of S. Kini, dali. Ano siya? Sometimes the open loop transfer function is also called the loop gain. Okay? Tama na siya. Itong klase nga transfer functions. Usually, ang gina-solve kay closed loop transfer function. Ano siya? Okay? And how do we do that on MATLAB? So ako ning butang dire. So let's have a script, no? So first, let us have the transfer functions defined. First is the controller. Diba the controller is just 1. No? We can also have the F1 tapos 0 ya 1. Diba? Kay mahog ng 1/1. Ano na? Okay? 0 kay para 0s plus 1 siya. Okay? Pwede ra sad ka c equals 1 diretso. No? If gain. Next, ato ang plant transfer function G. The plant transfer function is saman 0, 2. Diba? Because we do not have a 0. It's a constant sa taas. Or, pwede sa 2 niya. Sa denominator is 1 and 2. Ano? Kinsay ni sod? Sabi ko bago pa ni sod. Next, atong feedback. The feedback nga transfer function is 1/s plus 1. So, kini ato na ning sundugon. Asbon na to. 1 tapos 1 ana. So let's check. So kani c equals 1, g equals 2/s plus 2, h is equal to s plus 1. 1/s plus 1. So how do you get the closed loop transfer function? Diba? Atong closed loop transfer function is 2s plus 2 all over s squared plus 3s plus 4. So you make use of the feedback nga command. Okay? So let's say our kini siya is equal to, let's just say that's m of s, no? Para mas simple. So m is equal to, so we use the feedback na command. So atong arguments ani mainly 3. Okay? So system 1 is actually, or kana sys1, mao na siya ang GE. Okay? GE na siya. Diba GE is the controller cascaded with the plant transfer function. Diba? Imong kanang sys2, that's the feedback nga block. Feedback nga block is H. Of course, no? Actually, pwede ra to kutob if negative feedback. Pero, if positive feedback, you have to make sure nga imong i-indicate nga 1 siya kung positive feedback. Okay, mao nga positive 1. If negative 1, it means negative feedback. Okay? So, let's run this. Oh, di ba? Same. Same sa ato ang answer. Di ba? Kaya siya. Okay? Siya. Sige. So I hope na gets ra to, no. Easy ra kayo. Feedback ra jud. Feedback nga kanang correct spelling. If you want to know the documentation, you can check it on the internet. Okay. Next. Okay. Unsa man na siya pag input among transfer function sa control system designer, sir? So mo ang control system designer, no? If we go to the architecture, kini edit architecture, actually ang mga control systems wala sila convention na wala sila marag you can say nga common siguro. Wala sila common na or general na architecture. Magdepende na siya. But the most conventional feedback na control architecture is kini siya. Ano niyo makita sa inyong screen. I-zoom na lang ha if di maklaro. So you have F, no? This F is either your transducer or your filter. C is your controller. G is your plant transfer function. H is your feedback na block. DU, DY, these are both disturbances. No? DU is the disturbance at the input padung sa G. DY is the output disturbance. N is the noise. Okay. Sorry. Okay. So, sir, what if, sir, negative feedback ra gyud na siya, sir. Dili gyud na siya ma-change to positive. So, pwede na siya mamuusab, no? We go to loop signs, no? At YM, pwede nimo ma-change to positive. Okay? So, let's say, gamit ta atong mga blocks na to. Di ba natay controller, no? Natay C, which is, so you click this one, kana siya import data, nya pangitaa ang C, na i-highlight na import. Okay? Next, F. Do we have F? Wala. We can just put 1. Okay? Okay. Let's say 1 ang gain diha. Or, yeah, wala siya kanang gain nga more than or less than 1. Ana. G na to. O, nata G, di ba? Which is, kini. Siya. Highlight, import. H, sagdi na katong 1 nga nahimog 1 by 1 ZPK. How about H? Oh, import. Yeah, look for H. Na. Okay. So, if we press OK, mugawas imong body plot, imong root locus nga plot, o imong step response. So, we will not be looking at body plot because this is for frequency response. We will look at root locus for controller design as well as step response, no, to tune our controller. Okay? Whereas, no, sa ato ang MATLAB na environment, we can actually show the step response, no? And the root locus as well, no? For the root locus, you use R locus. Siya, no? Root locus plot of dynamic system. We can, for the step response, of course, we know the step, di ba? So, di ba ito ang total transfer function or closed loop transfer function is M, no? If we take the step of M, sa may naong anak niya. Ano siya, di ba? So, pareho na siya actually with this one. Okay? Sige, si Ana, no? Pareho na sila. Okay? Now, sir, what if ginahan ko mukuha sa, how do I know nga pareho siya? Because this is the transfer function from R to Y. Di ba R is our input, Y is our output. Which is this transfer function. Ano siya? Di ba, awa? Di ba? Input, output. So, kana siya ang transfer function. If we take the step response, that's from R to Y. Di ba? Ini. What if ginahan ka magkuha og step response from another part of the system? No? Let's say, balik ta dire, no? Let's say, ginahan ko from this one to C of S. We can also get that, no? Arita sa new plot, let's say, new step. No? Di ba mo man itong architecture? Ato rang make sure, no? Na we're looking at the same na architecture. Then you look for E to Y. Conventionally, wala na E to Y. Pero, pwede ta mag new input, output, transfer response. O, specify input signal, E. Specify output signal, Y. Compute input, output response with the following loops open. Wala, no? we will not open U and YM, no? Especially YM, no? Wala na siya. So if we plot E to Y nga step response, we can have this one, no? From E. So, similar na sila, no? Di ba? Ana. Okay? Sige. So, please kanang acquaint yourself with this tool because during analysis and analysis of feedback control systems, you will use this heavily, especially in the controller design na phase. Okay? Because the project that you will be working on, that's a non-linear, unstable na system. Okay, so ang imuhang ball, di na siya mo stabilize at a certain distance. Either mopilit siya sa electromagnet or mahulog siya. No? So the challenge there is to design an appropriate controller. Okay? Questions? Questions?
Nagawa na, sir.
Sige. Okay, so kana lang sa for today. For the next meeting, I will discuss analysis of feedback systems as well as sa paman to ha ako i-discuss. Kalimot ko. Katora analysis of feedback systems tapos maghatag ko og problem set. Okay? Which will be due 5 days after giving the problem set. Okay, so mao lang sana siya for today. Thank you so much and have a good lunch. Bye-bye.
Thank you, sir.
Thank you, sir.